Okay, hold on.
Try again.
Oh, yeah. Is that? Okay.
Perfect.
You can hear me now. Okay, good.
So if you could introduce yourself.
Okay, sure. I'm Tom Markland. I'm associate professor at Stanford. My group is a theoretical chemistry group, so we sort of bridge the sort of mathematics, computation, and chemistry divide. Is that the main intro you wanted, or is there anything else that you'd like in the intro?
Yeah, that's fine to introduce yourself and what you do now, and then we'll be asking more detailed questions then, so thank you.
Okay, awesome.
John?
Yes, good afternoon. I'm John Callas. I'm a physicist at the Jet Propulsion Laboratory. I managed the Mars Exploration Rover project for many years. That's Spirit and Opportunity, the two adorable Mars rovers that operated for almost a decade and a half on Mars. I then spent time searching for exoplanets. These are planets around other stars. And then more recently, I managed the fundamental physics program for NASA. And what we do in that fundamental physics program is we are currently exploring some of the greatest unsolved physical questions of our day. You know, what is dark matter? What is dark energy? And we're doing it from the environment of space. We're putting experiments into space that can be done more precisely than they can on the ground.
And we'll go down.
Okay. My name is Lan Dang. I am an operations engineer with the Jet Propulsion Laboratory. I do science data system operations for Earth science missions, which basically when we are measuring things from space, we take those measurements and we have to flow it through a pipeline of software before it becomes useful for the scientists to do science with.
Wow, I guess I'm going to be boring compared to you guys. I'm Jeff Weiss. I lead a team of solution architects at NVIDIA, and we're focused on ML operations. And over the last 8 years that I've been at NVIDIA, the company has changed, and we've turned into a company that's really focused a lot on AI. And there are a lot of opportunities and interesting use cases that AI can be used for. And even now, as you guys are, I watched the Python tutorial. A lot of the guys on my team, they're Python experts. These are the skills that will help you get there. So really interested in talking to you guys and understanding where you are going in your careers as well. So I'm looking forward to this discussion.
Okay, so the first question we have for you guys is, how did you find yourself in the line of work that you are in today? And we'll go in reverse direction.
I woke up? No. Well, to say that, I plan to be here 20 years, 30 years into the future would be silly to say that. I think that what I did do in my career was that I looked at what was going on in the industry and I charted a direction for myself. And oftentimes that direction changed over time. So I heard someone saying, I wish I was doing math or I was doing chemistry. People who know both math and chemistry are really valuable, right? So I think that the way I did it was through looking at the industry, sort of picking things that were my passion, things that would interest me, because honestly, I like doing things I like to do instead of things I don't like to do. So I did spend a lot of time figuring out what did I enjoy doing, what technologies I wanted to dive into. And that's how I charted my direction.
Thank you.
So the way that I ended up at the Jet Propulsion Laboratory was through an internship. Basically, a professor recommended that I apply to some program at the time. Like, I'm not a space geek, and at the time I didn't know the Jet Propulsion Laboratory existed. I didn't know where it was. I got lost on the way to orientation and came to my orientation late. But at the end of the day, I got to do this cool project called Rover Night Driving, where they were going to launch a rover that was no longer going to be solar powered. It was going to be powered by an RTG, and therefore they had the possibility of being able to drive at night. And so they just wanted to see what it was like to drive at night and take lots of photos and stuff. So I spent a lot of cold nights in the Mars yard And then after that, I went on to other different internships, not at JPL, but there was a career fair at my college. And as I was about to graduate, I went to the career fair, and I wasn't looking for a job. I was just wanting to see what was out there. And I chatted with someone at JPL, and I said, hey, I have a degree in computer science, but you know what? I don't really want to write code for people. Like, I want to write code to solve my problems, but I don't want to build software for other people. And she got kind of excited hearing that from me, and she took my resume, and then they followed up, and I ended up in my current role where they really wanted somebody who has a lot of experience with computers and can automate stuff, but doesn't want to go off and build software, and is really good at troubleshooting. And so I have been in my job for 15 years, and I really love it.
John?
Okay, well, maybe I'll tell a little story instead. So I got my job at JPL before the internet existed, so I'm dating myself a little bit. And so how do you get a job? My education was on the East Coast, JPL's on the West Coast. I wanted to work at JPL because it was a premier place for space exploration, for robotic space exploration. And it ultimately came down to I cold called a person. I got a name from a friend, and I picked up the phone, and I called them. And they gave me about 45 minutes of their time on that cold call, and it turned out to be a great experience, and it ultimately ended up in my getting a job at JPL. So don't underestimate the power of literally just calling someone. Not necessarily emailing them or texting them, but actually calling them. Because one of the things, I mean, you want to work in a field that's exciting, I would think. And if that field is exciting, other people are excited in that field. And excited people love to talk about what they're doing. And so it's true at JPL. We love to talk about what we do. So even though we might be a bunch of introverts, a cold call might be successful. So don't underestimate the power of doing something like that when you want to pursue that ultimate dream job for yourself.
Thank you. Okay, Thomas?
Yeah, so I guess it's good I'm going last. I'm perhaps the most boring of the three because it's basically I went to university and never left. So I did my undergrad at Oxford in the UK, and then I was a postdoc at Columbia University in New York. I was quite keen on the US academic market, and then I was there for 2 years, and then I moved to Stanford, where I've been since. I mean, the thing that really sort of drew me to this area was sort of the combination of areas. For a long time I'd been really interested in computers, and then when I discovered that there was an area where you could use computers and coding to learn stuff about how the world worked, I was like, this sounds like something that is really interesting, exciting, and so from undergrad through on, I was very keen that what I would like to do is to work in academia in the sort of area of trying to predict the properties of how molecules behave using theory and computation. So in that respect, I probably got the most boring track story here because I've been in academia throughout my undergrad and then onto my doctorate and my stuff in various different universities, constantly moving west from the UK. So yeah.
Okay, thank you. I was just going to follow up. A lot of times our students are young in their trajectories, and they're trying to figure out what they're going to do. And sometimes being a STEM major is very difficult, and they find it hard to want to continue on. So was there a moment or a specific turning point in your life that gave you the motivation to continue on, or gave you the goal of doing what you're doing now that you could share? And we'll start with John.
Okay. Well, I knew at a very young age that I wanted to do something in science or engineering, and that had sort of been my trajectory from the very beginning. So there wasn't a lot of uncertainty on that for myself. My challenge is I was interested in everything. I mean, I have an undergraduate degree in engineering. I have a doctorate in physics, and I teach mathematics here at PCC. So I literally cover the waterfront. But I am interested in everything, and that's what's tough. So my recommendation is do an internship. Internships are wonderful. They give you job experience. They give you the opportunity for an employer to preview what you might be as an employee, because organizations are really reluctant about hiring people because they're afraid they might hire the wrong person. But if you've been an intern for them for a summer, they already know who you are, and that is a great advantage. But what you intern is not necessarily what you get hired into. So I guess I really didn't answer your question, but I gave you advice to do an internship and follow what really excites you.
So my turning point to things is I used to be afraid of trying things because I was afraid to fail. And one year I just decided to say yes to everything. Didn't matter that I was overbooked, didn't matter that it was inconvenient, didn't matter that I didn't know how I would fit it into my schedule. I said yes, and I just did it, and I made it work. I didn't get a lot of sleep that year, and I drove like 100 miles a day. That internship I told you at JPL, I already had 2 part-time jobs, and I was going full-time school, and none of these places were located close to each other. And I was just like, I can suck it up for 10 weeks and do this. And so having that kind of driving me and being willing to deal with those moments of discomfort just to get the experience, and maybe to get the experience, like a whole bunch of experience in a shorter amount of time because I was doing them in parallel as opposed to sequentially. I think it really helped me, because even if there was one thing that was such a drag and I didn't like it, I had other things going on in my life that made me excited and kept me going and pushing forward. So don't be afraid to be uncomfortable, and also don't be afraid to fail. Right now, the stakes of you failing are much lower than later on when you have like more responsibilities and you have more to lose. So take advantage of failing now so that you know how to pick yourself up and recover from it, and you know that you can do that.
I find myself wanting to respond to what they said, but I'm trying to remember what the question was. So, the question of was there a turning point? There's been a lot of turning points in my career. So, if I was to, and I'm an old guy, so I don't think you want to hear all the turning points, right? But I will say that going through college, trying to think back, I went as a high school student. I went to Harbor College. I don't know if you guys know about that school. So it's a competing school. But there I learned recording engineering, and I became obsessed, because I was a guitar player, and I was going to make it big, right? And then while I was there, I learned about so this is a long time ago, but you could use these new personal computers to record your stuff, right? And so I got obsessed with computers doing that, right? And then, so I became a computer science graduate, right? And I went to Cal State University and got a bachelor's in computer science. While I was doing that, there were these other turning points. But while I was going through to get my degrees, there were some classes that were really difficult. I mean, I got to say, they were really difficult for me. And, one time I went to my dad and I said, hey, I'm going to quit college. I'm going to go and we're going to go tour, And he said, well, look, wait, hold on a second. You've gotten this far. You might as well just get through it, right? So I guess my discussion here is like, there's going to be headwinds in your career at school, and then later on when you get into the industry. Don't let those headwinds let you down. And she said something that I always say: be comfortable with being uncomfortable. Okay, that's it. This world is nonstop change from today out. Matter of fact, what I learned in college and got my degree, and I'm all proud of that, pales by comparison to the stuff that I learned in the 40 years since then, right? So what I'm saying to you guys is that this is just the beginning. And yes, failure, if you're not failing, you're not trying. That's the first thing. And I tell the guys on the team, I hire you to, well, I don't hire them to fail, but I want you to fail because that means you tried. And then when you try, just don't make the same mistake again, right? And let's keep moving forward. There's going to be lots of changes in front of you guys, right? So the idea is, though, to one, okay, here's the other thing I like to say. I'm going to blather. I'm an old guy again. That a lot of people go, oh, you're pretty lucky. You were lucky. And I think, yeah, I do. I feel personally lucky and blessed, that I've had the career that I've had. But when I think about it, though, there's really no such thing as luck. It's really preparation and timing. So my point in saying that is that you don't know what you're preparing for, but pick something and start learning it. Get hands-on, understand it, build your confidence. I have a manager that I work with. He says, build your belief system. Because if you believe you understand it, you can convince other people you understand it. And if you can do that, you can go anywhere, okay? And the other thing that I think is important is being able to articulate. You need to be able to articulate. So public speaking is like, they did some survey, it's the number one thing. People are more afraid of doing public speaking than dying, right? So that says a lot, right? So if you get comfortable getting in front of a group of people, do that. Do it as much as possible, okay? As much as possible, do the things that make you the most uncomfortable and get in there and do the hard work, and it will pay off. Because one day you'll come across somebody who'll say, hey, do you know someone who knows this? And you'll go, as a matter of fact, I do. And here's my GitHub repo of my Python scripts that I did this. And you could show it to them. You could talk about it. You could show your passion. And that is how you get in the door. And that's how someone builds confidence in themselves and the people that are hiring them.
Thank you.
That was my turning point.
And Tom?
Yeah, I mean, a lot of good stuff already said. I mean, I think when I sort of reflecting on this, the thing that I realized after the fact, which was sort of a turning point for me, is that I had this sort of idea of what I wanted to do. And there was a point where it was getting towards the end of my undergrad and you could apply to do research projects. And I had my mind set on doing something very particular. And at that point, I applied to all the stuff I wanted, and I got rejected by all of it. And then I sort of got the system sort of told you were getting rejected by person after person for research projects. And then I ended up getting the person I ended up actually doing later after my undergrad, doing my doctorate with, sort of basically sent this email, which I was CC'd on, and that basically said, oh, I guess somebody has to take him, so I'll take him. And that turned out to be the best. It wasn't really a decision in my life. It was not my decision to make, but it turned out to be the best thing in the sense that I'd realized subsequently that I'd overly narrowed what I thought I wanted to do. And in doing so, I didn't realize that the group I actually ended up in was a way better fit for what I wanted. And so the thing I would have told myself, that was in many respects sheer luck that ended up working out. But the thing it did sort of teach me is something that the other panelists have said, which is make sure that you are flexible and you take the time to look at what the other opportunities are, because in that case, I hadn't, and it would have been, I think ultimately in my career would have been a massive mistake if I hadn't, if it hadn't worked out the way it did, because that I was sort of forced into being more flexible. But I think obviously the piece of advice I'd give myself if I was doing this again was I should have been more flexible from the start and then exploring what the other opportunities in research were before I fixated that the one that I wanted was the one which actually I realized if I'd gone that down direction, I don't think would have worked out anywhere near as well as it did. So, and also, since one of the other speakers mentioned it, yeah, my public speaking was absolutely terrible as a student. I used to be able to, I couldn't give talks to anybody, and it took a lot of pushing through to actually be able to speak to audiences, which is obviously one of the things that when you're a professor, you have to do an awful lot in terms of teaching and stuff. But, and so, it definitely, if you are somebody who gets nervous, and I definitely get very nervous about public speaking, it's something, unfortunately, where it really does help to just practice, as the previous panelist said. I used to get so ill every single time I had to give a talk, even if it was in front of a small number of people. But obviously, the more you do it, the less the less stressful it becomes. It doesn't necessarily ever become completely unstressful if you're somebody who gets nervous in front of crowds. But it's for the career I work in, it's obviously a necessity to be able to go in front of a big room of people and talk to them.
Okay, well, thank you. So I'm the other moderator. I'm Tom Howe. It's a professor of applied mathematics at Caltech, that's across the street. And Yu Chang Chen is my wife. So I've been to PCC many times. So before I ask my question, maybe I should share a little bit of my own experience and respond to some of the panel said. I think that it is very important that when you do your undergraduate degree or graduate degree, that you really trying to conquer the fear to learn something completely new and learn it really well. And once you have that experience, you have established the confidence in yourself, then you feel very comfortable to move on to new challenge. Because most likely what you learn in college would not directly relevant to what you're going to do in your work or many years down the road. So I think it's once you build that solid foundation that enable you to navigate through different challenge, because whatever was popular at that one time for that decade may be out of fashion 2 or 3 decades down the road. So I experienced that myself. What I did in my PhD thesis still relevant to what I do research nowadays, but a lot of things have changed. The trend, the fashion has changed, right? So that kind of related to the question that I want to ask them to the panel now. So, please tell us some interesting new trends or discovery or innovation that you have seen coming out of your field. So maybe start with you. Yeah, John.
Well, I'm in the exploration business. Maybe I'll just give a broad stroke of things. You saw the previous talk about using Python modeling to model globular clusters and using gravity. And the professor mentioned about black holes and other celestial objects. When we look at the universe, and we've just launched the James Webb Space Telescope, we are realizing that the universe is made up of mostly dark material. What do we mean by dark material? We don't know. We call it dark matter and dark energy. In fact, 95% of the mass energy of the universe is in this dark sector. We don't know what it is. The stuff that makes up you and me, what we call protons or hydrogen or heavy elements, that makes up only about 4.5% of the universe. So, when I went to school, if you only knew 4.5% of a subject, you got an F. So right now, our scientific world is getting an F on understanding our universe, which means that there is so much to explore and discover out there. We know so very little about our universe, and we face some serious challenges down here. So, when you look at the textbooks and you think, oh, everything's been discovered, when you take your chemistry class and go, oh, everyone did those same experiments 50 years or 100 years ago, the reality is that there's so much to explore. And so keep exploring. So that's what I would say is our greatest challenge and our greatest opportunity.
So
Thank you. Yeah.
I was going to say that this is going to go out to the computer scientists and people in IT out there. In my space where we do data science processing for earth science data, we're starting to get more and more data from our instruments out in space. It's coming down in terabytes and petabytes. And so we've had to change our software pipeline to be able to scale out to deal with that processing. And so we're actually leveraging technology such as what powers Netflix, like putting things in Amazon Web Services, doing things in Docker, and kind of adopting a lot of things that have already been used in industry to provide your internet services, to provide Netflix, all your streaming platforms. We're adopting that, and we're modifying it to suit our kind of niche field of doing data processing. So that had been something that had been going on for several years. And when I heard about it several years ago, I kind of jumped on the bandwagon, and right away I tried to get myself inserted onto that project because I knew that cloud was the future, and I wanted to learn that technology before we started using it. So with the missions that we have now with SWAT, which is a collaboration we have with the Callas, the French space agency that launched in December. We have another collaboration with India, NISAR, that is launching next January. They're bringing down so much data that we actually had to put all of our computing services into the cloud. And we're all having to learn all of these new technologies and how to navigate in this space. So there's a lot of opportunities out there if you want to join my staff. I have a comment about that later on. And so that's the exciting thing here.
Jeff.
Wow. Okay, ChatGPT. Did I get it? Is that the answer? Did I get it right? Should we? Well, okay. So my role in my team and what I've been doing is, I've been a part of what customer-facing activities, right? So the interesting thing that for me is what our customers are doing with our technology. And it's really exciting because I get to talk to a healthcare provider that's detecting cancer in x-rays using AI. Or I talk to an entertainment company that's using natural language processing to figure out how to communicate, how people can ask it questions, that it can answer questions back. I work with other companies that are developing autonomous drive vehicles. There's all sorts of neat stuff going on with the technology, with the stack, right? And so the question is, well, then hey, what's interesting, Jeff? Well, what's interesting to me is how these different groups are trying to figure out how to harness this power. And so I guess you were asking about technology, so I'll just talk really briefly. So instead of us handwriting code, move this bit over there, or read this array and then do something to it, we're literally letting these neural networks look at the patterns in them and then recognize objects, and then be able to make predictions on what's being asked of it later. So what you basically are doing is taking all this data, like she was talking about. There's so much data coming in, they can't even stream the data in fast enough, and some of the data is being lost. And so it's even possible now to use neural networks to sort of pre-process all the data that's coming, because there's a lot of data that may not be relevant, okay? And so there's pre-processing, there's data labeling and things like that. Once you have that, then you can use that data to train a neural network. Now, like I said, it could be for intelligent video analytics. It could be for natural language. It could be a chat bot. It could be any sort of thing. But once you're doing that, then what are you going to do? Well, you're going to take this trained neural network. Like all of you guys, you're going here, you're coming here, you're taking classes, you're training your brains. And then we have all that data, we have a very small or maybe medium-sized neural network then that you can then put out to do a specific task, right? And so now there are groups of teams trying to figure out how to put these out on production. I mean, how many millions of people are now accessing ChatGPT? Well, someone has to scale that out. So now there's the production level of that. So Kubernetes and operations and so forth. And then once we retrain the model, how are we going to put it back out into the network and so forth? So there's all this different technology that builds this solution that kind of seems like magic, right? But the truth is, there are guys out there that are in computer science right now. They're learning how to scale out that neural network so millions of people can hit it at the same time. There are other people on the other side that are figuring out, oh, well, it's not that accurate. How do I make it more accurate? How do I, And so there's a lot of exciting things, technology. So and that's not an advertisement, but there's a lot of resources on NVIDIA's page. You can go there and you can download Python code to start training a neural network, but also out at Stanford. So I've taken a lot of the Stanford courses and so forth, and here at the school. So there's a lot of free resources to get started. So go ahead and take a look at that. And it's a great journey. Between now and the next 20 years, it's going to change. It's all going to be different. So you can get on the merry-go-round. I don't know what it is. You can get on the treadmill now, and you won't be behind, because in 20 years you will be the experts.
Great, thank you. Tom, yeah.
Sorry, yeah.
Yeah.
So theoretical chemistry is one of these areas that sort of, not quite during my lifetime, but but that much longer, has gone from being sort of one of these sort of niche areas of chemistry to being something where, because we get to benefit from some of the stuff that the previous panelists were just talking about in terms of commutation, that the sort of stuff you can do now, even from when I started doing research in this area about 15, 20 years ago, the sort of stuff you can now do is truly amazing. And it's also made it that much more accessible, in the sense that there are calculations that when I was starting my PhD, you couldn't, would take you'd have to write a big grant for computer time, and now you could do the same calculation on your own laptop or whatever. And this has really pushed the sort of problems we can look at in theoretical chemistry. Particularly the most interesting area, I think, at the moment is to look at very complex sets of chemical reactions sort of in real time, by being able to solve the way that the electrons behave simultaneously to the dynamics of everything that's propagating, and really watch these processes unfold by solving obviously the physical equations you need as you go. Previously, this was much more limited to things like systems where the chemical bonding was not changing, but now it's getting to some very exciting times where you can really look at, at high accuracy at sort of chemical reactions undergoing, look at what the mechanisms are in both biological and material systems. Another area which links to what was previously being said is that definitely, other than just the general improvements in the efficiency from the theoretical chemistry community, and also the improvements in computing that we get to benefit from sitting on the back of. Definitely, in the last couple of years, machine learning has become a very big aspect of interpreting chemical data and things like this, and really making it something where one of the things we're really pushing at Stanford a lot now is we have a we have a computational track to our entire as a separate area of chemistry, mainly because now it's becoming obviously more and more common for to have both that even groups that are doing experiment to try and either interpret data or simulate their data in addition to it. And so theoretical chemistry sometimes gets called computational chemistry, and obviously sometimes people ask me what the difference is, and realistically it's just because the field has got so powerful and broad in what you can simulate these days that sometimes you can do obviously computational experiments where theory I think has traditionally been associated more with the development of new theoretical methodologies or ways to simulate chemical systems, but obviously now there is an equally big branch of computational chemistry where some people are really trying to just do experiments with computers, and that's been enabled by obviously developments in this field over the last, realistically the field of over 40 years, but a lot of it has accelerated a lot in the last 20.
Okay, thank you. So you guys have mentioned lots of positive things that students should do, like internships and being willing to make mistakes and these kind of things. But in reflection of your story, is there anything that you wish you had done differently in the past that would have helped you to achieve your career goals? And we'll start with you, Jeff.
So anything I would have done differently? Wow. Lots, but I can't undo it. So I just keep going forward, right? Are you asking for something in particular?
Yeah, just something for guiding, because I think sometimes when students see us as professionals, they think everything just went very smoothly and we just had these perfect lives, and we know that sometimes that's not the case, right? That there are bumps in the road.
So there's a book out there called Essentialism. I don't know if you guys have seen it or read it. I highly recommend it. It's Greg McGowan, maybe. But basically what that book says is this, that you are in charge of your career and what you do. And if you don't prioritize what you do daily, somebody else will, okay? And so it's pretty interesting in that it gives you a lot of ideas and ways to sort of focus on things that are a priority for you in your life rather than somebody else's priority. That being said, I think it's important also to look at the value or understand the value of building relationships with your peers and your cohorts. So he mentioned that he cold called somebody and he got his job. I did that too, right? But it wasn't my idea to cold call this person. A friend of mine that I worked with said, hey, why don't you just call over there? And I go, you can't just call over there. And he said, yeah, you can. I go, okay. Then I called him. And it turns out that, this was one of the most influential things in my life that happened because that person has done, I've worked with that person for many years. My point being is that you got to find people that share your belief and your passion, and then stay with them. I don't mean just, go work with them and so forth, but, keep in touch with them, understand what they're doing, see where they're having success, maybe help them out, right? And then also, it's important to be a part of a team. There's a saying, lead, follow, or get out of the way. But the point being is that it's not bad to follow someone who's leading you somewhere and you're learning from them. So always be listening. Always listen. Listening is very important. And it's not to say that everything that anybody says to you makes sense or anything, but it's up to you to decide, hey, that was something that I'm going to put in my toolkit, right? So look at people, their good habits, and you could look at their bad ones, right? So as a manager, my role is to recruit top talent, right? To nurture them, to maintain them, to make sure that they're doing something that they are proud of, that they're doing their life's work. Okay, so that's a tall order, right? But it's okay because I hire people to tell me what to do. So that's one thing. And then the last thing I would just say is you could experiment. Influence without authority is a very important part. In other words, cat herding. Seeing if you can be a part of a team and influence. It's practice. You learn that as a skill. Anyway, so I guess I just went on a huge tangent, but at the end, I think that there's been a lot of things that I go back and go, oh, I could have done that better. And being able to understand that and be humble and say, hey, I could have done that better. I'm going to fix that next time. Don't repeat the same mistake over and over again and move forward.
Thank you.
Tangents on Pi Day are okay.
What's that?
Tangents on Pi Day
Oh,
are
okay,
okay.
good. I made a mistake. Oh, boy.
So I was thinking about this question about if there were things in my past that I regretted. And what I came to realize is the way that I ended up where I was through a kind of a long and windy route. But if I had not made the mistakes that I did and I hadn't taken this long route, I would not be living the life that I have now. And so the mistakes that I made before, they were painful. They were like not enjoyable experiences for several years, but they made me who I am today. I learned a lot from the mistakes that I made before. I learned how to be more empathetic to other people. I learned to understand that when someone irritates me a lot, I kind of put myself in their shoes and I can like have that no longer affect me because I know they're having a bad day. I've had a bad day. I've been unpleasant too. And I think it's made me a much better person overall. So I don't want to erase the mistakes of my past. I want to learn from them, as Jeff stated. The thing that I kind of do regret a little bit is that I used to be very isolated and introverted, didn't really like reaching out to people. And anyone who knows me today knows that when I mentor young people, I just say, go join a meetup, go talk to these people, go join this cohort, because you can't do things by yourself. The only thing that you learn by yourself is what you know. If you're willing to go with other people and listen, you will learn from them and you will multiply what you learn.
Thank you. John?
I think the only thing we'll add, which was essentially said, is that you don't regret failure, you regret not trying. So don't be afraid to try those different things, whatever it is. Don't be afraid.
Thank you. And Tom?
Sorry, yeah. No, I would echo the panel. I think most of the things I don't regret are things that I, for whatever reason, was too scared to try. And I think if I went back and did it again, particularly in the position that a lot of the people in this in the audience, I'm sure, are in a position where, if you're undergrads or grad students where you're looking at this sort of stuff, this is a time where you have an awfully large amount of flexibility to see what's out there and to sort of pivot your career. And obviously, I think that's the one thing. If I was going to say, could I have done something differently? In a way, as the other speakers said, it's hard to say that I necessarily regret any of the things, but on the other hand, I do think that if there was something I was doing again and I got to go back to be a university student, I would maybe have explored more different research opportunities at that time where there's still the flexibility to try lots of things and not, and see what works for you. Particularly since the area I work in, I think, is one of these areas that one of the things at Stanford I've been trying to do over the last couple of years is get theoretical chemistry more accessible. It's one of these areas that sort of has a tendency to drive people off because it's sort of, but on the, which is why I mentioned so much about the sort of computation aspect of it these days, because I think the traditional thing of, oh, this is lots of people just working on blackboards trying to write a load of stuff is semi-true, but it's not very true. And I think it puts people off saying, oh, I can't possibly be a useful person in a theory lab in my, sophomore year or something. It's like, it's true, we do use a lot of like formal theory, but on the other hand, getting, doing these things and seeing them early really does help. And so that's definitely something I'm personally keen on doing. We also have a preview day at Stanford for this reason, for people to join via Zoom, even when they're early years of stuff, and see what it's like to be a theoretical chemistry graduate student. That's you Google chemistry preview day Stanford. There's a theoretical chemistry preview day, and that's really is to try and lower this bar to what's traditionally been, I think, quite an intimidating area of chemistry. To just say, look, give it a try. True, you're not going to know all the theory needed to do stuff when you're in very early years of college, but that doesn't stop. There's plenty of inroad projects into that sort of thing, I think that's sort of semi-answering the question, which is, I wish I'd been more ambitious in just trying things out before, early on in college.
Okay, thank you. So in the interest of time, I want to give you guys a chance to ask the panelists questions. So if any student or any of our audience has any questions, you can ask it now. Yes. Do we have?
What is the quality you see students when they apply to an internship that stands out from the rest?
Did you hear her?
Yeah, what is the quality we look for that stands out when someone applying for an internship? Enthusiasm, I would say. We want people who are passionate about exploring something new. So that's what I would look for.
I look for things on their resume that show that they don't just do stuff in school. They have outside interests. They've worked on projects, particularly in my field, which is heavily towards people who do computer science, who do some kind of programming. If all the projects that I ever see in your GitHub are the ones that you did for school, to me that means that you only ever did schoolwork. I have no sense of what you can do as an independent person. When we bring on an intern, we will mentor you in the hopes that you understand what it's like to do the job, but we're not going to handhold you through the job. We expect you to look at a problem and come to us with questions. We are not there to kind of like hold your hand every step of the way. And so I look for some sign that you have an interest and you've done stuff outside of what you were required to do.
Well, she said it. I can't say it better than that. The only thing that also, and I don't hire a lot of interns personally. We do hire them at our company, and so I think that there's a little more wiggle room for interns. But people who come to me that apply for recs that I might have open, everything she said. And then one other thing is, do some research before you talk to the person that you're interviewing with. In other words, so many times I've gotten on the phone, I go, "Oh, tell me what you know about, this company," and they didn't log on and look at the web page, right? And so if, like she said, most of the job is going to be research. You're going to show that you're a self-starter, that you can figure things out on your own, and you're motivated and you have passion, right? And the best way to do that is say, "Oh yeah, I know about what you've been doing." And now look, you could do some research on the person that's actually interviewing you too, but be careful there, because you don't want to become off stalker-like, right? So let's be careful there. But the point being is that if you know and understand what's going on and you can articulate it, that'll raise their confidence a lot.
Do you have anything to add, Tom?
No, I mean, obviously, internships, I guess there's graduate students, and then there's undergraduates who work in my lab. Definitely, yeah, enthusiasm. I think actually the thing that I always try and assess, which is often hard to assess from a paper application, is just how well people are willing to deal with failure. A lot of research is failure, and a lot of the people who academically are good but then don't translate into research are people who've been put in academic environments where they don't feel like failure is an option. And of course, most of research is failure, because by definition, if you're doing an interesting research problem and you've picked an interesting research problem, there's a reason it's unsolved, and therefore it's often a lot of the procedure is failure. And if you're the sort of person where that's going to cut into you every single time, then but you're therefore going to shy away from the challenges because you might fail at them. That's always the thing that translates to somebody who might be academically really strong, who's not going to be necessarily successful in research. And so obviously, first I look for people who are just ambitious and willing to try new things, even if they are stuff, but also I obviously try and work with people to say, it is natural to fail. This is part of the scientific process. And so, but definitely, as the other panelists said, enthusiasm often comes hand in hand with that. If you're enthusiastic, when you realize that you've just spent 3 months doing something that actually led to a null result, then the enthusiasm will carry you through that sometimes, which is so that the ability to deal with failure and enthusiasm are obviously for the sort of scientific endeavor in general is important. I think.
Okay, so it looks like we're about 5 minutes over. So if someone had a dying question that they definitely wanted to ask, we would take one more. Does anyone have anything? Yeah. Oh, we have very interesting 2 questions.
My question is, well, as a math major, right, there's this battle between pure and applied, and which one's better, which one's stronger. Well, I would say pure, because applied is just putting theory into practice, right? But each their own. But anyways, I was saying, as more for like the computer scientists and the data science with all this new machine learning stuff, it's more for, I would say most of the people are working on the technical aspect of it. Would you say that learning more about the theory of machine learning, for example, like neural networks and deep learning, I could study graph theory, right? Mathematics. Would you say that would make me a stronger applicant against someone who has better technical skills, but not as strong as a theoretical foundation of it?
Wow, that's a tricky question there. I think I hate to say it, but both, right? I mean, if you can't, the theoretical is great, and understanding. I read through LeCun's book, and it's like, wow, there's all these algorithms and stuff. But actually understanding and doing the process is important as well. So I'm sorry, I waffled on you here, but I think they're both important. But also depends on what role you're trying to go for and what do you want to do, right? So that would have an effect on that as well. But I think the theoretical is important, but being able to do something with it is even more important.
And then we had one more hand up, so I didn't. Okay.
Thank you so much for being here today and sharing your experiences with us. My question is, what is your daily 24-hour day looks like?
I'll take a shot at that. It's paperwork, it's boring meetings, it's putting together reports that no one ever reads, it's all that stuff that you don't like. But it's a necessary part of what we do that enables other people, because I lead a team, it enables the team to do phenomenal work. So there will always be the bad with the good. And understand that that's what you have to do in order to get to do the good stuff.
So I could tell you what I did today, but I was technically on vacation today. But I'll tell you anyway, because this is why I work at JPL. This morning, I took a really cool woman that I had met to the lab to give her a tour, because one of our employee perks is we get to give people personal tours of the lab at all of the public tour spots. I don't know if you've ever tried to get a public tour to JPL. I hear it's like trying to get concert tickets sometimes. But if you know somebody who works at JPL and they're feeling inclined, they can give you a personal tour. So I gave her a personal tour, had her meet some of our high-level people because I really wanted her to give a talk at JPL, and I needed to talk to the people who actually arranged those talks. So we had such a fantastic conversation with her. We met so many people. I showed her all of my favorite spots. I got to get a tour of an area I hadn't seen before. And then I came here, and I'm here with you. And one of the things I love about JPL is outreach, and STEM is really important to us. We're actually encouraged to spend some of our time to do education research, outreach, whether it's volunteering for a program that JPL already has, or even doing things on our own, or like going to talk at a school, or
Like this.
or going to do some kind of maker fair and doing some kind of manning a JPL booth. What I did this weekend was at the Southern California Linux Expo, we had a bunch of JPLers in a room, a STEM activities room, and we were doing some of our JPL education activities. We had straw rockets, we had the star-shaped origami, and then, I don't know if you know this, but JPL has this strategy card game called NASA Space Voyagers. And when I found that out, I had to go make it and play test it with a bunch of kids. So we have some feedback for the JPL Education Office when it comes to their card game rules, but we're very excited to play it with our interns.
Okay.
Can I have your card? So I used to, when I was at another company, Sun Microsystems, I was the lead SE at JPL, and I had a badge, and it's incredible. Walk around there, and I used to go into rooms and talk to researchers and help them figure out how to get their life's work done. So is your question, what did I do today, or what I do every day?
Your normal day.
Okay, so everybody, I don't know if you guys noticed, when we all went remote, like people just figured, I'll just put stuff on everyone's calendar. I don't know if you guys saw this, but I used to work, 10-hour days, and suddenly I had 12-hour days, right? And it was like, oh yeah, we're just sitting behind the cameras and stuff. It's really to get out in front of people. I really like being in front of people. So what I learned by doing that was, one, I got to get away from the computer. So what I do every day, the first thing I do every morning, and my wife's gonna, say, oh yeah, sure you do. I walk 5 miles at 6 a.m. Okay, and yeah, sometimes I still get a con call, and I'm doing con calls from that. But I guess what I'm saying is, take care of your health first, right? I mean, whatever projects you got going on, if you don't have yourself, your brain straight, you're not going to be able to make it through the day or the week. So that's one thing, right? Your health should come first before any project that you're working on. So the other thing is that, so just recently, this month, next week, we're going to have something called our GTC conference. And it used to be live in person, but we went to a virtual version of it for the last couple of years. Next week, we're going to have some GTC sessions, right? I highly recommend, if you're interested in learning about the theory, there's hundreds of sessions that you can log into and get access to for free. So this last month, every day, I've been helping people on my team, or I've been developing sessions that we're going to be presenting next week, for example. But to your other question, we'll get on calls with customers who say, hey, we're having problems with this, help us figure this out, or we're building out this, AI center of excellence, and we need help with this. So it goes from customer facing to helping people with the specialty to retraining myself. So I literally, and all my team, we have what we call key objectives, or KOs, and the team, they talk about their outcome-based goals for customer interactions for the year, for themselves as a specialty. Everyone has a deep dive specialty that they can help everyone else on the team or with across the whole company. And then they have 20% of their time focused on what they're going to train themselves so they can keep ahead of the curve next year. And we go back and we rate ourselves on this. So the answer to your question is, I exercise, I spend time with my customers, I use my specialty to help other team members, and I retrain myself.
Okay.
Uh-oh.
Okay,
Yeah,
so
I
I
don't
have
think
to,
you have any more
I'm
questions.
so sorry, but we're,
Ask you a question.
okay.
I'm the one.
Oh, okay.
I need to explain what is GTC because most
A lot of people nodded their heads, so I figured it's a GPU technology conference. Okay. So you can go to NVIDIA.com and you can find out about it. There you go. Big
Okay.
advertisement. It's a big conference. Take a listen.
So thank you so much. In the interest of time, because the next session's about to begin, please join me in thanking all of our wonderful panelists for being here today. Thank you so much. And thank you guys for coming and supporting this event.